Hello everyone, myself Catherin Antony, currently a third year student of College of Engineering Poonjar, doing my BTech in Computer Science and Engineering, and also serving as the V chairperson and link representative of IEEE SBCE Poonjar. And I will be dealing with cyber security in smart grid. Okay, let's start. Before Before talking about cyber security in smart grids, let's see about electric grid and also smart grid. I hope everything is clear. Okay. I hope I'm audible. I hope I'm audible. Okay. I hope I'm audible. So, let's before moving to cyber security in smart grid, let's see what an electric grid is, a smart grid is. So let's see what an electric grid is. Um, some Our current power system has evolved gradually since about 1880, when Thomas Alva Edison brought up the electric light and figured out the principal idea of how the energy shall be distributed to surrounding area from a centrally located power station. There are actually three pillars for an electric grid, that is generation, transmission and distribution. Electric grid is the network through which power is generated, transmitted and distributed to consumers. There are several key pieces of infrastructure that are built to support the delivery of electricity to consumers, and it is comprised of generating power plants where the electricity is produced, transmission lines, it allows the electricity to be transported over long distances, substations where electricity voltage is increased or decreased, and we have transformers to increase or decrease the electric voltage. Then we have distribution lines, which is similar to transmission lines but for lower voltages. The grid was actually created to solve the problem of geographic separation between electricity production and consumption. Electricity is often produced far from where it is used, so infrastructure needs to be built to connect the two. Prior to the invention of the modern grid, electricity producers each developed their own distribution system for delivering electricity to customers. And this system was costly and often led to underused infrastructure and wasted electricity. The modern grid was invented to allow various producers to shape infrastructure for production and distribution, which led to increased reliability and lower cost. So let's see how exactly does the grid works. After electricity is generated, the voltage is stepped up at the substation. This voltage increase allows electricity to travel long distances while minimizing the amount of electricity loss. Once it reaches its destination, there is another substation that steps the voltage down to a level suitable for distribution lines that deliver electricity to consumers. The electrical grid provides electricity to various consumers with varying needs. For instance, industrial consumers are large facilities like manufacturing plants. Then we have commercial consumers like our office buildings or high rise towers, and residential consumers like our individual homes. Electric grid, we could say that it is one of the most important invention in our modern world. The centralized nature of the grid has made it an ideal structure for large scale electricity production. However, some of the grid infrastructure is outdated and is not capable of accommodating small scale electricity generation technologies. So there comes the need of smart grid. Now let's see what a smart grid is. Smart grid refers to the electric grid enhanced by information technology. It uses information and communication technology to gather and act on information such as information about the behaviors of suppliers and consumers. Actually, everything is in an automated fashion, and it helps to improve the efficiency, reliability, economics and sustainability of production and distribution of electricity. And also, smart grid allows a two-way communication of electricity rather than a one-way flow. We have seen that electricity grids are actually based on one-way interaction from the stages of generation to consumption. But smart grids, on the other hand, they integrate the action of all users in the power network using computer-based remote control and automation. Actually, this two-way interaction is what makes the grid smarter. Smart grids enable a real-time data collection concerning electricity supply and demand during the transmission and distribution process, making monitoring, generation, consumption and maintenance even more efficient. And it is actually known to combine computing, communication and sensing techniques into our current power grid networks. Actually, this helps to empower neighborhood information exchange, decentralized control, two-way power transmission and efficient demand response. However, this emerging system also introduces new security concern, that is the cyber security issue, because of high importance of cyber infrastructure, and I will be dealing with that, and I will give more details on that. We know that the information technology can make the grid smart, like real-time monitoring, advanced information analysis, automated control, but still they will make the grid vulnerable. So let's see about cyber security. The key elements of cyber security is integrity, confidentiality and availability. And what is cyber security? Cyber security is the whole process of preventing damage to the confidentiality, integrity and availability of information. And availability means it has to provide, or it provides only authorized parties to access our information, and only when it is needed. And also it guarantees that unauthorized people or devices cannot access the system. Then integrity, it prevents tampering of critical data in sensors, control commands, software and electronic devices to disrupt data exchange and decision making. Then confidentiality, it is ensured that the stored and transmitted data can only be accessed by the relevant receivers, and also it prevents unauthorized users from accessing data to protect our privacy and security. See, smart grids require real-time monitoring of parameters such as frequency, power, voltage and current. This means that the integrated elements of the system can automatically optimize its operations, monitor itself and protect against the cyber attacks. Smart grids include, there are two separate transmission lines in smart grids. One is the power transmission line and the other is the data transmission line. The communication infrastructure provides coordination and data flow through the network entities bidirectionally. The integration of different technologies such as energy storage technologies, renewable energy sources, electric vehicles, remote reading systems into smart grids causes the communication infrastructure to become complex. This actually leads to problems in ensuring the security of data in smart grids. Our smart grids are cyber physical systems. Therefore, in order to ensure security in all cyber physical systems, three important security principles which we have seen before, that is confidentiality, integrity and availability, have to be met. There are 7 areas as shown in the picture in our smart grid, where almost all of them communicate with each other. Each of these 7 domains interfaces has different security requirements in terms of the availability, integrity and confidentiality of data. Additionally, we have to even look for our privacy, quality of access of data, preventing unauthorized access, ensuring system continuity and quality of services. These are the cyber security requirements in the smart grid domains. The vulnerabilities in smart grids can be exploited by attackers or users, and it can be consciously or unconsciously, and also causes damage to distant levels to our system. Conscious attacks intentionally aim to harm any of the principles of the system. Hackers, organized crimes, cyber crimes, terrorists, anti-governments, everything comes under conscious attackers. And in addition, we have end users who have smart meters. They may attack to the energy system or energy infrastructure for various purposes like energy theft, fraud, sabotage, vandalism, like so. Unconscious attacks are attacks that are intentionally committed by end users who are generally uneducated in the cyber security issues. And we have the conscious attackers who actually manipulate these users, and they attack the system, and this attack can cause many serious problems to our system. Some consumers also attack certain system components to reduce their electricity bills, and they may also aim to provide financial benefits by changing their generation and consumption information or by accessing the billing system. So attackers are classified according to their targets or motivations. There can be many reasons, like for a hacker, he or she may be motivated like profit, information gathering, protest, challenge or enjoyment, and terrorists aim to cause massive damage, so people are afraid of them. They study about the target's network and operations, and then they launch a vital attack. Then we have disgruntled employees who are really dangerous because they know about the system's weaknesses and procedures. Then comes the competitors. They may just only eavesdrop rather than make damage. Therefore, they are really harder to detect. So these are the attacker types in smart grid. Now let's see the attack types in smart grid. The attack types in smart grid, the threats can be divided into three groups. That is physical threats, environmental threats, and cyber threats. While the physical threats involve unauthorized threats to physical accessibility, environmental threats include threats such as natural disasters, extreme heat, extreme cold, like so. Now let us see the two types of security attacks. One is the passive attack and the other is the active attack. In passive attack, the attacker aims to obtain the transmitted data to learn the system configuration, architecture and normal behavior. It is difficult to detect such attacks because there is no change in the data. For this reason, we should focus on prevention rather than the detection of passive attacks. Now comes the active attacks. So active attacks aims to affect the operation of the system by modifying the transmitted data or by adding manipulated data, and active attack results in the violation of availability, integrity and also partially confidentiality principle. Then the active and passive attacks are carried out by the third parties, and it can be conscious or unconscious. So the vulnerabilities in the calculation systems and in the software may be the main reason for large power failures. Therefore, we should make it a high priority to address the security of electricity networks. So it is important to examine the cyber attacks carried out in critical infrastructure. One such cyber attack is the Stuxnet. In 2011 or by 2010-2011, it was confirmed by the Iranian government that the Bushehr nuclear power plant had been attacked. This complex attack is called Stuxnet. This attack on the Iranian nuclear power plant once again demonstrated how important cyber security is. Now, it is the most destructive example of a cyber weapon. This malware was distributed using a USB stick and infected all Windows Windows machines in the system. Later, a special control system used to operate high-speed centrifuges that help enrich nuclear fuel. This centrifuges, or this operator, or this control system was searched by the malware. When the malware found this control system, it updated itself automatically and caused a physical malfunction in the centrifuges, and reported that the system was working steadily by providing a false feedback to the control system. Actually, the Stuxnet is not a traditional worm. It is more of a complicated, or we could say it is advanced and effective, like so. It is almost 20 times more complex than any other previous malware. And also we could say that it is a hybrid of worm, Trojan, rootkit and virus. Mainly it happens in 4 steps. It spreads like a worm or virus using a Trojan, then discover the target system, then destroy the target and evading of the detection, which we have seen in the Iranian nuclear power plant. Stuxnet attack vectors cover distant parts of the system. It was actually designed to target a specific SCADA system using at least 4 vulnerabilities of the operating system, and so it caused the destruction of some over 1000 Iranian nuclear centrifuges. Its targeted security vulnerabilities of the control system, and its success actually raised many questions about the security of such critical system. So it is really important to take the security of power networks more seriously. So now let's see some of the attacks, some cyber attack models. One is the denial of service attacks. Denial of service attack is a sort of cyber attack that the hackers distribute misleading instruction to a server or a network, disrupting their services intended users temporarily or indefinitely. Or to be more specific, hackers or attackers flood the targeted machine or the resource with excessive requests so as to overload the systems and prevent the genuine request from being fulfilled. The DOS attack typically uses one machine and one communication connection to flood the target, and there is another similar attack which is called the distributed denial of service attack. It uses multiple machines and communication connection to flood the target system. This attack actually is more serious, or it causes more consequences because it is impossible to stop the attack, and by simply blocking a single source cannot stop the attack. So the existing denial of service attacks, or the distributed denial of service, it occurs at different communication layers in a smart grid, like the application layer, network and transport layer, media access control layer, and the physical layer. When it comes to the application layer, the attack is to target the application layer by over exercising specific functions or features of a server with the intention to disable those functions or features of a server. Since millions of ICT devices in the smart grid are equipped with limited computational abilities, they can be potential victims of the application layer based on the denial of service or distributed denial of service attacks. And when it comes to the network and transport layer, this attack mainly relies on extremely high volumes of data to slow down transmission bandwidth in communication channels and eventually degrade the access of genuine users. This kind of attack may lead to serious degrade for communication preferences from end to end. Then this attack or at the MAC layer, it can intentionally tamper with the MAC parameters in order to access the network by degrading the performance of those that use the same communication channel. It is known that the data at the MAC layer is transmitted using three frames, in which control and management frames are really susceptible to this denial of service attack or distributed denial of service attacks. And when it comes to the physical layer, the denial of service attack and the distributed denial of service attack, actually it is launched by signal jamming, and an attacker only needs bridge to communication channels, which is actually easy to be launched. That's about the denial of service attacks. Now let's see what is a false data ingestion attack is. A false data ingestion attack can disturb the power system state estimation process and then mislead the system operator. This actually result in a negative impact on the power system. The main key component, or one of the main components, key components of the of the central control center is the state estimation. It processes and filters raw measurement data from the SCADA system and then manipulates the state of each bus. A large amount of power system applications rely on the results of state estimation. The operation and control functions of energy management system can be intentionally misled by giving false and malicious data information. Except disturbing the power system operation, a valid FDI can also have influence on the electricity market, which is one of the domain of our smart grid, and also the distributed energy routing. The aim of the attacker is to obtain additional benefit and profit. Generally, what they will do is that they will purchase a virtual power at a node with some low prices, and they will send it at a higher prices using this false data ingestion attack. And another type of false data ingestion attack is the named energy deceiving attack, and which can affect the distributed energy routing process. Since each node can perform as an energy consumer or producer, the smart meter at a node can perform as an energy consumer or producer, and this smart meter at the node will decide whether it is a producer or consumer by looking the measurement. The measurement demands and requests can be shared with each other by communication among nodes. So once an attacker controls a smart meter, he or she can inject forged energy demand as well as false supply message into the grid. The balance between the demand side and the supply end will then be broken, and this can lead to an increase in the cost of energy distribution and also disturbs the effectiveness and energy of the process. So to make our smart grid even more smarter, we need to find the solution to withstand these cyber attacks so we can protect the system and the information. So detection is the primary process so that we could take a proper countermeasure to defend the attacks. The first first let's see how we can detect the DOS attack. We have already seen what a DOS attack is. The DOS attack, to be more specific, can be launched anywhere around the world by the access to the communication network like the internet. Generally, there are several schemes for detecting DOS. We have signal based, packet based, proactive and hybrid detection schemes for detecting the DOS attack. And what a signal based detection is that this detection is located at the physical MAC layer. There will be a detector to detect the DOS attacker, which can receive and measure the signal strength to detect the occurrence of an attack. If there is an attack, then it will raise an alarm. The next one is packet based detection. This detection can be implemented at every layer to measure the transmission result. It is a normal and effective method since DOS attacks can always result in packet loss or delay. We know that every data is sent in the form of packets, and thus the degradation of network performance. Next comes the proactive method. This detection is to proactively send probing packets so as to identify DOS attacks and test or measure the status of possible attackers. Then comes the hybrid method. In this method, this method is to design one combined approach that consisting of the two or more schemes which we have discussed. Okay, now we have detected the DOS, so let's see how we can defend the attacks. Generally, there are two methods to defend the DOS attacks. One is the network layer mitigation and the other is the physical layer mitigation. And in the network layer mitigation, it is actually most widely used or most widely applied for defending DOS attacks. And generally, there are a number of approaches for the network layer mitigation. One is the rate limiting. This method is to impose a rate limit on a set of packets which are identified as vicious by the detectors. Then comes filtering. The filtering method uses a filtering mechanism by comparing the source addresses of packets with blacklists so as to screen out all questionable flows. By this way, these packets will not be sent to the victims. Reconfiguration method is to reconfigure network architecture by either adding more resources to the victim or isolating attacks. Then comes the physical layer mitigation. Wireless networks are widely applied in local area systems in smart grid. Thus, wireless jamming attack should be the primary DOS attack in wireless based smart grid. In recent years, jamming resilience schemes are developed to reduce the jamming attacks. The scheme is developed in either a coordinated or uncoordinated way. So let's see about the coordinated and uncoordinated protocols. When it comes to coordinated protocol, this method has already been applied in the area of wireless communication. There are three schemes: direct sequence spread spectrum, frequency hopping spread spectrum, and shift spread spectrum. However, the secret is supposed to be confidential to attackers in direct sequence in DSSS and hopping pattern in FHSS. This assumption is not correct in open communication environment. Thus, we could say that this protocol is weak when attackers launch targeted attack if they have the information of protocol. And when it comes to uncoordinated protocol, this method randomly creates a secret for each communication and block attackers from obtaining enough information to interrupt the transmission. Since this method does not require to process and assume secret with each other, it has important potential for secure wireless communications in a distributed situation. However, uncoordinated protocols also have a disadvantage that they have to negotiate a secret before initiating data communication. Thus, there will be a delay in the performance. So, we have seen how we could defend the DOS attacks, and we know that smart grid can improve efficiency of energy management, reduce the electricity bill of consumers, accommodate more renewable energy sources, and reduce greenhouse gas emissions. So, many countries are undergoing a massive transformation to smart grid. This innovative framework will introduce new cybersecurity issue which is very common in internet. So it is really an important concern to ensure cybersecurity in smart grid. So we have so far seen about the important attack models and corresponding methods to defend it. So if you guys have any questions, then you can put forward. I hope I was audible. I had some network issues. I really hope I was audible. I hope I was going right. Okay. So you guys can contact me anytime. This is my mail ID and my WhatsApp number. Okay. Thank you everyone.